Hello everyone, my name is John Cooper. I'm the CEO of BAR Technologies. Thanks very much indeed for the introduction. The presentation's got rather a grand title and in fact is not quite correct when it says a lifetime of decarbonisation. Actually, my contribution to decarbonisation has only been 5 short years. And in fact, I was involved 15 years in Formula One prior to that. So I think there's great contrast between Formula One and maritime decarbonisation. They couldn't be more worlds apart. But I'm very pleased to be involved in the industry now. BAR Technologies actually stands for Ben Ainslie Racing Technologies. So Ben, probably the most famous sailor in the UK, that's for sure. Many gold medals and world championships, and now involved in the America's Cup. And this business that I now run was born from the 2017 America's Cup cycle. At the end of each America's Cup cycle, the rules change, and it very often has a vacant period in between one cup cycle and the next, and very often the engineers are lost to the industry of Grand Prix racing, America's Cup racing, but also the tool sets, the skill sets. And Ben and a guy called Simon Schofield and a guy called Martin Whitmarsh started this business to actually bridge that gap. Let's not waste all of the technology that we've developed in what is the world's best yacht race and actually bring commercialisation instead. So we are a small inventor. We rely very heavily on simulation, and we use those tool sets all the way through our business. Whatever we design, we do not design by a human. We actually train neural networks to interrogate potential designs and then choose the design that best fits. So we are performance simulation, design and engineering, naval architecture, and one really important aspect in the marine industry, everything moves slowly. That's not just the atmosphere and the pace of life in the marine industry, it's actually the control engineering. So rudders move slowly, engines move slowly, and actually some of the projects you're going to see require actually faster movement and more detailed movement and more accurate movement. So we do have and hired quite a big team of control systems engineering from the automotive industry, from Formula One, from aeronautics, and brought them to Bartec. So now we have a really rounded skill sets in terms of more traditional naval arcs and people driving the business forward. So the second lie is on this graph, and actually you'll see, so it is a company dedicated to decarbonisation, but one of these projects that we have done is certainly not green. But we did need to do it when we were actually starting the business because we had to pay the bills. So actually there's the America's Cup boat on the left-hand top. We actually fitted some foils onto a Princess yacht. Why did we do that? We did that for comfort. We did that for actually better handling of that vessel, but we also did it for 30% fuel saving for that particular craft. So actually just changing the displacement of the boat actually changed the fuel efficiency, and saving 30% is obviously a fairly significant amount. This next boat is a very good example of how we use our design tool sets. So instead of saying it's a crew transfer vessel, so this vessel takes technicians to the wind farms. So rather than all of the others, which are catamarans, we said, right, what do we need from a boat that takes technicians to wind farms? We need stability, because a lot of the technicians are electricians and they're not seamen. So we need them turning up for work, not green, but actually a normal colour and ready to perform and be fit. And also we need an efficient boat. So we're making all these fantastic green energy in the middle of the ocean, and currently we're using some quite dirty boats to take people to fix them. So actually we need a very clean boat. So this boat has got a large main hull, as you can see on the left, and actually under the water on the right there is a torpedo outrigger, a swath-style outrigger. So it's actually a 30-metre Polynesian canoe with 2 foils on. And the result of that is over 30% fuel saving and over 70% less vertical acceleration. which means it's a very stable platform. Equinor love it because they're saving over 30% of fuel, and it's on charter in the North Sea to one of the biggest wind farms in the world. Have you spotted the one that's not green? It is the surface to wet submarine, which we were asked to design, and it is it's a massive technical challenge, so we couldn't resist taking it on. So we were paid a retainer to actually design, develop, and actually make this very, very special craft. It does 50 knots on the top of the water, and then shuts the diesel engine and then submerges to become a wet submarine. So it does have Navy SEAL divers inside, and as you can see, it's a pretty James Bond looking vessel, very successful vessel, and that vessel is now owned and operated by the company that commissioned us, a company called SOCSEA24. Now on to the real decarbonisation and probably our future. We have two products, and I'm going to go through all of these products on the bottom shelf here. So Bartek Wind Wings, that red boat there, I'm going to show you a video in a minute, but it's over 200 metres long. It's a bulk carrier taking grain around the world, and we're putting some very high-tech sails on the top of that bulk carrier, and those are about 50 metres off the deck. So you can see the extent of what modern sailing means. In the middle, we have some slightly smaller wind wings, very similar sort of type of thought process, but just in a smaller version. The second project I'm going to talk about is the Bartek Aero Bridge. So have a look at the accommodation block at the back of the vessel. It's basically a block of flats that just pushes through the water, creates a horrible draft, horrible drag, and our efforts here, I'll talk about it in a minute, is actually a low drag accommodation block. As you can see, it's two accommodation blocks with a big hole in the middle. Now, we've got some very, very clever people, but when you look at it, you think, well, that's not brilliantly clever, but actually that accommodation block does provide thrust to the vessel. And lastly, a foiling launch. It's actually 6 seaters, but there is my CTO and my Chief Operations Officer enjoying a jaunty trip around the Isle of Wight. And I was going to ask you which one you thought was not green, and of course it's that one. Right, 3 dives into decarbonisation. Wind wings.
This project is truly revolutionary. It's never done, specifically not at this size and this scale.
Perhaps it's more than commercial. We believe in decarbonisation of this planet.
Innovation doesn't exist without taking risk, but we think that this technology is really a game changer. The industry is an extremely hard industry to decarbonize, so there's not many tools that you have. So it's really important that we, as users of the maritime industry, are also going to get involved in some of the innovation and really move the industry forward.
Cargill walked among us and said, could you actually invent a wind propulsion system for us? A system that we could put on our vessels and decarbonise the deliveries of food around the globe. They probably know more about shipping than Bartek. We're the techie guys knowing how to invent things, and that partnership's been really, really strong. So we fed off each other, and that's about energy, expertise, technical know-how, and drive and determination. It's what we've done together. It's not easy, otherwise everybody would be inventing wind for ships.
We were looking for interesting technologies that we could bring in-house in order to make the maritime industry greener. Then we came across all technologies for the assisted wind propulsion as a super cool technology to embark in. If you look at the rate of the savings, how much you can save the technology, wind propulsion is one of the biggest levers you have.
There are so many energy-saving devices in the market today. Wind-assisted propulsion system is one of the very few solutions available that can achieve fuel savings by 2 digits, and it can be retrofitted.
One of the strong learning points in the shipping industry is it's all about partnership. Without a very strong collaboration, Cargill, NC Shipping, Costco Shipyard, Port Technologies, and the underlying technologies, we would not have been able to bring these to the water that fast.
The wind wing is made out of 3 elements. Each of them are 37.5 metres tall. The middle one is 10 metres wide, and then the front element is 5 metres wide, and that's a duplicate of the rear element, which is also 5 metres wide. And they work together So each of those elements has a central pivot, and the whole wing also rotates, such that we can actually present that wing in many different angles, in many different formats, depending on the wind angle and the wind speed.
This innovation is extremely important for the maritime industry because it is a technology that is actually using wind, which is a free fuel at the end of the day.
Each of these wind wings is saving 1.5 tons of fuel a day. That's 4.65 lower CO2 emissions per wing per day. That's next level savings.
We hope to gain a lot of insight from this solution, which would open the doors to expanding the application to other ships in our existing fleet.
The real fight is the legacy fleet and these new builds in the future. To bring the grain in the case of Cargill or other goods around the world and using far less.
Where we're going to spend our time on is how can we scale this technology not just on our own fleet moving cargo, but also very much in the rest of the industry.
So that's very much a reality now. It's been sailing, and I mean sailing, for a year. We've picked some really good partners to start with. Cargill's the biggest private company in America, and of course Mitsubishi don't need any introduction, they own the vessel. For our second vessel, we chose, or it chose us, of course, the owner chose us. This is the Berger Olympus by Berge Bulk. It is the world's most powerful sailing cargo vessel. As you can see, it has 4 wind wings on it. It's actually chartered to Vale in Brazil, and it runs from Brazil to China and back. It's really important that you get the operational capability right of any wind propulsion device. You've got to be able to get it out of the way of tugboats, you've got to be able to control the power, and you've got to be able to ensure that loading and unloading is done unencumbered. So there are a number of different positions that we have the wings in. Folded at sea, that's also how the boat comes into port, because it's inside the beam of the vessel. Active feathered, we encourage people to fold the wings at 50 knots, which is of course quite a big wind, but we're able to depower the wings and have the wings up to 100 knots, which of course is a very fierce storm. And then portside operations, there's one further fold to get them outside the hatch covers. I'm not going to go through this in detail. In fact, I'm not going to go through this at all in the interest of time. But it's basically our design tool set that I was talking about in our introduction. I will go through this. Actually, what's the best analogy for a wind wing? It's actually an inverted aircraft wing. So I travel in the cheap sheets around the world, so when I'm coming into land, you can actually see the nose coming out the front of the wing and the tail coming out of the back of the wing, and it's a nice sort of cambered shape. And what the aircraft's doing is actually slowing down and providing upward thrust as it's slowing down and landing nice and gently. So you take that thought process and invert the wing and put it on a ship. What you're then doing is creating a mechanism to give you forward thrust. Add some very clever control systems engineering, and you've got a workable solution for sailing around the world. I think the video did a better job of this, but actually our technology is worth 1.5 to 1.6 tons of fuel per wing per day. So that Berger Olympus was saving over 19 tons of CO2 a day. And each individual in here, if you're European, you are using, your footprint is about 10 tons of CO2 a year. So if you think about the saving of that vessel is the equivalent of 2 of you in the audience for each year. So significant. It's real, it works. Here is some data. I'm not going to go through a huge amount of it, but basically the green is when the wind wings are up and working. The sandy colour is the transition to the wind wings. We call it feathered, but turned off or folded, and the red is when they're in fact folded or wings off. And lots of different people use these wings in different ways. You can turn the engine RPM down to minimum RPM and save a lot of fuel. You can leave the engine alone and actually make the vessel go quicker, one of the biggest sort of green things for big ships is to go down to slow steaming RPM, but actually owners can have a little bit of both with wind wings and actually tune ship seat, which is also on board, to decide when you want to arrive at your port, how much engine you use and how much wind propulsion you use. There's so many debates in maritime that talk about hydrogen, ammonia, methanol, and actually wind is free. It genuinely is free. It's used at source and never diminishes. I can't think of a better fuel. So we talk about this 1.5 to 1.6, but actually in open ocean, there's some very big savings to be had. So 24-hour period at the top, so a whole day. True wind angle, so sorry about the technical bits, of 143 degrees off the bow, so just behind. True wind speed 20 knots, so not a very big wind, and we're saving 5.6 tons per wing per day. So open ocean, much more saving, and closer to the ports, of course, less wind and less saving. I'm going to skip through this, but basically the model, the simulation model that we used to design wind wings, and then we use it to simulate the savings for the owners. One of the key things that we had to do right at the start was it accurate? Could we then be really confident of giving guarantees to our future owners? And that's what we are now doing because the correlation is so good to what we thought it was going to be. Operational modes, there's that nice sort of camber shaped, so it's equivalent to an aircraft landing, equivalent to a bird landing. If you see birds just before they land, they push their shoulders up and they make a nice round shape with their feathers and they spread their feathers out. This is exactly the same. That's just nature's way of creating that shape of slowing the bird down just before it lands. Active feathered, if you point all of the wings into the wind, they provide very little drag and no thrust whatsoever. And the biggest issue with any of the wind propulsion systems is the worst possible scenario. How do you keep your vessel very safe? And so if your captain, if he or she decides not to fold the wings at 50 knots, decides to steer straight into a storm, and then the ship loses power, you've got your, unfortunately, perfect storm of mistakes. What happens to the wings? As soon as the ship loses power, actually there is a positive accumulated charge, and that charge releases the gearbox and releases its wings into what we call passive feathered, which is a little bit like a sort of a weather vane, so producing no thrust. I'm going to skip through. We have a suite of tools on board. So no sailors required. The wing gets put into the right condition for the weather that it is encountering live, so we don't have to predict the weather. There's lots of diodes and lots of sensors and lots of strain gauges on board, and we can put not only record the thrust but put the wings in the right position. So, second dive into decarbonisation. When we were looking at vessels, when we were deciding how big the wings would be, where we would put them, with a lot of CFD, a lot of analysis of the pressures that you would see around the vessel. And at the back, that's the accommodation block. So the first square is where the crew sleep, and the second square is the funnel for the engines. And you can see that blue area behind, which is basically drag. So it's like, which is more aerodynamic, a Ferrari or a transit van? It's the transit van. No, it's the other. So the Ferrari is more aerodynamic, the transit van is more draggy, and this is a transit van basically on the back of a ship. So we thought, surely we can do better than that. So we designed that aero bridge that I'll again show you in a minute. Instead of having one accommodation block, let's have two accommodation blocks. Let's share the ground floor so the crew all work nicely together, and that's where the sort of the messes are and the gym is and all that sort of stuff, so everybody still works together. And when they go to sleep, they don't just go up one set of stairs, they go up two sets of stairs into two accommodation blocks that are like foils, and then the bridge goes across the top of that. So there's a traditional one on the left, and there's our fairly funky Bartek Aero bridge on the right that we're now going out to shipyards throughout the world and to owners. We've actually sold the first one of these, and the owner loves the fuel savings, but he certainly likes how cool the ship is going to look. And I think actually aesthetically, they're not that great, and hopefully we can make owners and charterers more proud of the way the ship should look. So performance, so you've got conventional and our aero bridge comparisons. So where you've got the wind at 60 degrees from the bow, the conventional block has a negative impact on the vessel of 11.4 kilonewtons, and the aero bridge has a positive impact on the vessel of 1.4 newtons. So there's a difference clearly of 12, and actually the aero bridge at that stage is providing literally thrust to the vessel. And at 30 degrees, conventionally, the old style combination block is giving 33 kilonewtons of drag, and the aero bridge is only 15 kilonewtons. So again, a very, very big difference. And I won't go through the last one, but you get the idea that actually this is a very low drag solution, and actually on occasion one that provides actual thrust. And it looks cool. Third dive into decarbonisation. So we all know about electric cars. We all know in the maritime industry about hydrogen and ammonia and methanol and diesel, what's going to be the next fuel. Everyone says, well, why can't electric be the next fuel? And it can have its part to play. There can be some battery storage, there can be some incremental power, but it's not as dense as dinosaurs, and it's not as dense as those other fuels, so we need to be careful with its use. The reason that cars are suited to electric is there is not much rolling resistance to a car. If you jumped into a 15-year-old car and you took your foot off the accelerator, the engine would brake the car actually, and it would stop very, very quickly. Not so anymore. You take your foot off the accelerator and your car coasts a long, long way. So all of the rolling resistance has changed on a car to enable it to use better fuel efficiency, quite frankly, but also enables it to become electric. And a boat is no different. So if the boat was in the water, that would be actually too much resistance to be able to use a fuel like electric. I think by flying the boat, so by picking the boat up and actually taking it out of the water, instead of pushing a hole through the water, you're now pushing some foils through the water, and the drag is reduced by 90%, and the requirement for fuel is also reduced by 90%. So we do things quickly. So this was from concept to reality in only 14 months. The potential owner came to us and said, I have a really good looking rum runner, actually. So an ancient boat that used to literally take rum from Cuba to Miami Beach and drop off in Prohibition days. He said, I love the look of that boat, but obviously we can't run around in that boat. We want an equivalent for modern day. Would you please take a beautiful wooden boat and make it fly? And we said, yes, we will. So we did that in 14 months. We repurposed some actually LG cells, which are used in Volkswagens. We built our own battery cell. We consulted on the powertrain, so we've got a very small motor. It's a rocket motor, in fact, about this size. But these are all good prototyping, so when we actually develop it and bring it forward more for the mass market, we'll all be ready. So, takeoff mode 14 knots, that's the owner, proudly shown off. The range is actually quite long. A lot of boats do not have great range, or electric boats, because of this phenomenon of pushing the boat through the water. So water is nearly 100 times more dense than air. So a car is pushing through air largely, and a boat is pushing through a mixture of air on the top side and water on the bottom side, hence the flying, as I'd say. It's got a top speed of 30 knots and a cruising speed of 22, and those foils come up through the hull if you want to go onto the beach for a barbecue or you want to go into a shallow port. So we've really thought again about how this is going to work, the user profile, and adapt to the design. So the motor's 60 kilowatts and the battery is 150, so about twice the battery requirement of a car. And of course, all of that means that you can bring this boat back to the marina and plug it into a normal car charger and overnight charge your boat as if you were charging your car. So we love design. There's a lot of sailors, there's a lot of high-performance people. We feel like a sports team. When we'd made this boat, when we'd launched the boat, I don't know if everybody knows, but there is a blue ribboned event for lots of different boat types around the Isle of Wight on the south coast of the UK. And we were invited to see if we could beat that, and the record was just over 6 hours. For going around the Isle of Wight in an electric boat, and we thought, well, let's drive a little bit of razzmatazz, and we invited the Royal Yacht Squadron to make sure that we had a big cannon off the start and a cannon off the end, and we invited the BBC and several other news outlets, and here's the result. So we just shaved the 4 hours off the previous record, so it was a good day and it went well. Thanks for listening. That's my presentation for you.
What size of vessel does it have to be to have those big sails on? And what size of sea, kind of open space, wind capacity do you have to have?
Two good questions. So I think the big wings, the 37.5 metre, we're great at naming devices at Bartek. So the big wing that's 37.5 metres is called the Bartek Wind Wing 37.5. So that wind wing is good for vessels that are largely over 100 metres long. So when you get into MR2 tanker size, Kamsarmax size, that first vessel was a Kamsarmax. We would advise putting that wing on those big vessels. But in terms of wind propulsion, in terms of thrust, get as much on as you can, quite frankly, because it's free to use the wind. But the reason that we developed the smaller wind wing was actually for vessels probably below 100 metres, or vessels that didn't have much deck space, or if they had a membrane tank on top, so it was more difficult to fit quite a big wind wing. Actually, we're now developing that. In fact, we have designed and developed the smaller wind wing for those type of vessels. So largely about 100 metres is the cut-off.
And in terms of your audience and marketplace, I was just moderating a panel of investment people who have money, and we were talking about the percentages of companies and those in the market who are actually able to finance some of these retrofitted technologies, particularly new technologies, and how it's quite barrier for some. Where are your kind of audience or market for these super wings? Is it a small niche number of companies, or is it quite accessible?
No, actually, there's a lot of companies out there. We know that we have to influence lots of different stakeholders, but the charterers are big stakeholders. So if you're looking at let's say tankers, of course they're your oil giants, but there are also your chemical tankers, there are also refined product tankers. So all of the household names that you can imagine, they are potential customers. On bulk carriers, it's Cargill, but all of the other companies that bring food, grain, and other aggregates around the world. So actually our customer base is actually vessel owners, and then they say, we've got some great wings on our vessel, would you like to charter that vessel? And that's to the companies that are actually utilising the vessels to take their goods around the world.
Because they're going to have cost savings.
Exactly.
And then my last question is on the Rolls-Royce of the speedboats, the foil. I mean, do you think it's a possibility that we can expect to see flying boats going around our harbours and coastlines in the future?
I guarantee it. Honestly, no doubt in my mind whatsoever. There are various startups around the world doing less glamorous versions than the one we've done there, because that is quite a lot of money. But we, in fact, will be making an announcement in a few weeks that we're partnering a very well-known and very large boating company to bring our technology to their boats. And that's the way that Bartek work. We've only got 50 or 60 people, so we can't do everything ourselves. So we've designed and developed the first off. It works, boating companies. And the boating companies, they're great at making boats, but obviously flying a boat does take a little bit more, talent's the wrong word, but different skill sets. So our offering is to actually bring what we've learnt to the mass market such that actually everyone can enjoy their flying boat.
I think you lived up to expectation. At the beginning of this presentation, I was concerned the title was too exciting for the content, but I mean, that was really inspiring in terms of inciting our imagination. So, just one last question off the actual question sheet. Okay. So, as part of the conference today, one of the aspirations is that delegates and presenters contribute to the New Society and Sea Charter that will help to anchor stakeholders and strive towards a fair, more inclusive and sustainable approach to working in the blue economy. So we're asking each of our presenters a question to contribute to that, and you as the audience to think what would be on your charter. So John, you chose the question, do you have any suggestions for solving societal and sea-related challenges?
Yeah, I picked very quickly because it was question one, yeah, wasn't it?
You can have a look.
I can't see, I haven't got my glasses, but it's fine, I'll remember, don't worry. I think actually there's some really good schemes actually going. So the European Union, hats off to them, they've got their ETS, which has now come to the maritime sector. So they're collecting a carbon tax, and some other taxations around the world are of similar vein, but I've got to say, as I said, hats off to the European Union. They are now using all of the monies that they have collected through the emissions scheme and actually reinvesting that into green technology. So what better way of using that tax and actually saving CO2? So I think if there was one thing I would encourage all bunkering locations, because I really think that's the way that this tax will eventually be collected. It will be extra money when you fill up your ship. So anybody that bunkers the Singapores, the Rotterdams in the future, if that tax is used appropriately, then we'll be well on our way to the IMO targets.
Fantastic, thank you. I'd like to thank John on behalf of the audience for a brilliant presentation.
Thank you very much. Thank you.